In this video, we're going to review what the AP curriculum calls Unit 3. Now, most of the stuff that's in here actually comes from our Chapter 5, Program Structures. Unit 3 is about Boolean expressions and if statements, mostly. So we've got Boolean expressions, simple if statements, if-else structure, else if, which is extended branching. We're going to take a look at how to figure out whether expressions are equivalent or not, and we're also going to look at comparing objects. Now, when you compare objects, that means you have to be working with something that used the comparable interface. And remember, in order to implement the comparable interface, you have to write the compare to method, which is going to compare two objects. The very first thing we're going to look at is expressions that have relational operators. Now, the relational operators are your greater than, less than, greater than equal to, less than equal to, equal, and not equal. Those are your 6 relational operators. They're going to evaluate to a Boolean value of either being true or false. So once you have one of those relational operators, you've limited what kind of values that expression can come out with to being either true or false. An if statement affects the flow of your code based on the Boolean expression. So when the expression, when the Boolean expression attached next to the if is true, it will do the statement or statements inside of the if. And when that Boolean expression is false, it just skips them. Now, one of the things that they're really going to test to see if you understand here is the usage or not usage of braces. Remember, if an if statement has braces, it'll do everything inside of those braces. If not, it will only do the very first line after the if. So if you only have one thing that you want to do, it doesn't need braces. Sometimes they may put multiple statements after the if with no braces. Remember, only the first one is considered to be part of the if. Now, two-way selection is when you make use of the if-else structure. So when the Boolean expression attached next to the if statement is true, it'll do whatever statements are inside the if. Again, braces, optional. Maybe you're doing more than one statement, whatever. When that Boolean statement that's attached next to the if is false, you're going to do whatever statements are included with the else. And this is why the else statement doesn't need a Boolean expression. It's literally going to be everything else. So whatever makes your if false is going to enact the usage of the else. And again, if you only want one thing to happen for the else, you don't need braces. If you have a bunch of things that are going to happen for the else, then you will need braces. Extended branching is done by using the if, else structure. Okay, so this is multiple branching. You can have as many branches as you want coming out from this structure. It only performs one section of code though, and that's the first one that it finds to be true. So if you go into the if and it's not true, if the Boolean expression that's attached next to the if is not true, it will then start checking out the Boolean expressions attached next to the else ifs. And you may have 1 or you may have 30 of these. But the first one that it finds that's true, it will do. As soon as it finds one that's true, it will skip all the rest of it. And if it doesn't find any of the Boolean expressions in either the if or the else ifs to be true, then it will run the else. So make sure when you have an extended branching situation that you always finish with an else, because that's there to catch every kind of logical thing that you didn't put in your ifs or else ifs. If statements can be nested inside of other if statements. However, very oftentimes we can avoid the nesting of if statements by using compound statements. So using your logic operator and, if you, instead of saying if this is true and then putting another if inside of that, if this is also true, you could just do if this and that. Make sure that you know how De Morgan's law works. De Morgan's law is what we use when somebody is trying to negate either an and statement or trying to negate an or statement, remember you're going to have to negate each statement separately, and you're also going to have to change the symbol that's in between. So negating A and B is going to lead to you having not A or not B. And negating the statement A or B is going to lead to you having the statements not A and not B. So that's De Morgan's law. That makes these two things are equivalent on either side of the equal sign. Also remember that if Java cannot determine the truth value of a compound statement, if Java can determine the truth value of a compound statement by only looking at the first term, Java will not evaluate the second part. This is what they call short circuit evaluation. Now, why does Java do this? Java does this in order to save time. So for example, if I'm looking at an AND statement and I know that the first part's already false, there's no need to even look at the second part, because when you have an AND statement, you need both parts to be true. So if the first part's already false, the second part doesn't matter. In an OR statement, if the first part's already true, then it doesn't matter what the second part is, because an OR statement only needs one of the parts to be true, and you've already accomplished that with your first statement. So remember, short circuit evaluation is one of the things they love to test on to make sure that you understand what Java's actually going to do in the problem, not just what it looks like it's going to do. User-defined objects themselves cannot be compared by using the double equal sign or the not equal symbol. If you do this, if you use the double equal symbol or the not equal symbol for user-defined objects, you'll actually be comparing their memory addresses simply to see if they are or are not stored in the same memory location. But it won't be comparing any of the characteristics. So for example, if you wanted to compare two bank accounts and check and see if they have the same bank balance, this won't work. Or if you wanted to check to see if the bank balances are different, this won't work. This is only for intrinsic types that you can do this. So it will, though, however, if you do use the double equal sign or the not equal symbol, it will compare the object's memory locations. And you can also compare an object to null, just to see if it's blank. So I want to give you an example of how to use this. Let's say we have a class called dog, and we've created an object called X by running the constructor of the dog class and asking for memory to do this. Now, over here, I'm trying to show you what's happening in the RAM for these lines of code. So we now have a memory location assigned the letter X as its name, and this would store our first dog that we've created because we ran the constructor and we've asked for memory. So this orange block right here represents the memory location for dog X. Now let's say we created a second dog called Y. One of the things I want you to notice about dog Y is we did not ask for new and we did not run the constructor for dog. So this is declaring that there's going to be a dog, but we never ran the constructor and we didn't ask for memory. So there is no actual space in our RAM for dog Y. So check out what I'm going to do right here on this line of code. If dog Y equals null. Now this is actually going to work. It's going to check to see if that dog is empty. Null means empty, which it is. What I'm going to do now is set Y equal to X. In other words, we are creating a link from the declared dog Y to the memory address for dog X. So these two dogs, X and Y, are actually linked together because dog Y doesn't have its own memory location. It's using the memory location for dog X. In other words, if later on after this line of code, if I make a change to dog X's name or weight or age, then dog Y is also affected because dog Y is using the memory address for dog X. So if I change its weight or its name or its age, those changes will also be reflected into dog Y. So if I change the weight for dog X to 30 pounds, dog Y would now say that the weight is 30 pounds. It would match whatever dog X is because they're sharing the same memory location. All right, this was a very short review, but you're now ready to try the questions in Personal Check for Unit 3, Parts 1 and 2.